Hello, this is Tracy. Welcome back to Math 135, Introduction to Statistics. Here we're going to talk a little bit about potential sources of bias and other potential issues that we can have with statistics. So I am going to encourage you to read the notes that I posted for this section first. Hopefully you've already looked at and thought about these questions here, and what you're doing now is just checking your answers to make sure you did it correctly. So all I'm going to do is go through and answer the questions that we have on these notes. An article in Journal of Nutrition titled Daily Consumption of a Dark Chocolate Containing Flavanols and Added Sterile Esters Affects Cardiovascular Risk Factors in a Normotensive Population with Elevated Cholesterol states. So the article with that fancy title states the following. Results indicate that regular consumption of chocolate bars containing PS, plant sterols, and CF, cocoa flavanols, as part of a low-fat diet may support cardiovascular health by lowering cholesterol and improving blood pressure. This article states, results indicate that regular consumption of chocolate bars may support cardiovascular health by lowering cholesterol and improving blood pressure. That's awesome. Eating chocolate is good for me. Wow, I'm going to go out and buy lots of chocolate. Wait a minute. This is in a section called Identify Possible Sources of Bias. What source of bias might exist in this study? Well, the last sentence. This research was supported in part by a grant from oh, nope, not an eraser. Let's get my pen. Mars Incorporated. Mars, maker of Mars bars, says chocolate bars are good for you. Why might that be a problem? This is a self-funded study. Mars bars has a vested interest in the results. Mars bars wants you to go buy more chocolate. So they want to say chocolate's good for you, so people will spend their money buying chocolate. Self-funded, self-interest study. This doesn't mean the study's bad or wrong. It just means we better take a very careful look at it because they want to get particular results, and that want can bias the actual results. All right, number 2. At CMC, we are going to have teacher evaluations be available online. That way students can fill them out only if they want to. What's wrong with this type of a study where students have to get to a computer, go online, click on a link, and make the effort to fill out the survey? This is what we call a voluntary response sample. Voluntary response sample. This is a pretty standard abbreviation. And what that means, if people have to make the effort to go out and fill out this study, we're not going to them, we're not putting in their hands and saying, here, you fill this out now. We're asking people to take effort to go to the site for the study and fill it out. Who's going to take the time to do that? Typically only people with very strong opinions, and usually that means people with negative opinions. So we're not getting an accurate sample to reflect the population as a whole. Voluntary response studies are usually the worst. Voluntary response samples are usually the worst kind of samples that we can get, and our results are likely to be wrong when we consider the population as a whole. Unfortunately, that's sometimes the best we can do. Okay. Potential sources of bias in the next 2. Fred needs to gather data for his stats class. So he asks his nursing student classmates to fill out a survey for him. What's wrong with this? Well, the students that Fred is asking are all from his nursing class, and they're the ones hanging out with Fred. These people may be different in an important way from the population as a whole. There's no guarantee there are. They may be just like everybody else, but it's possible that nursing students have some things going on. If the survey was something like, how many science credits are you taking this semester? Nursing students are not representative of the population as a whole because nursing students need to take a lot of science, anatomy, physiology, chemistry, biochem, all that good stuff. So this is, we're not getting anybody else involved. This is a convenient sample. And so what we have is potential missing data. We are not including, we are not giving everybody a chance to participate in our study. When we get a convenient sample, the people in our study may be very different from the population as a whole. All right. Sarah's boss asks her to gather data about consumer preferences for a product name. So, Sarah opens up the phone book and starts calling people on their landlines. What's wrong with this? Well, she's calling people on their landlines. Who even has a landline anymore? Typically older people or folks who live where they don't get good signal so their cell phones don't work in their house. This means that a huge chunk of the population doesn't even get to be included in the sample. Don't even ask them. Don't even get to those cell phones. So again, this is going to lead us to missing data. Missing data. And the other name for that is undercoverage. We're not giving everybody a chance to be in the study. If we don't give everybody a chance to be in the study, our sample is not representative of the population. All right, let's look at the problems on the next page. Come on, change pages for me. There we go. All right, so again, we want to identify potential sources of bias. Jennifer chooses a random sample of homes to visit to conduct a face-to-face poll. Of the 120 residents who answer the door, 30 are willing to answer her questions. What potential sources of bias do we have in this study? There are a couple things going on here, but the one that's just screaming at us, 120 people answer the door, but only 30 are willing to talk to her. This is what we call non-response. A lot of folks get this mixed up with a voluntary response sample. It's not. In a voluntary response sample, people have to come to you to participate in the study. People have to reach out and call you. People have to send something in the mail to you. People have to go to your website. That's a voluntary response sample. This, we go to the sample and the sample says, I don't think so. In non-response, this is where you call somebody on the phone and they hang up on you. This is where you knock on the door and they shut it on your face. Non-response. People choose not to participate even when you take the effort to go to them. And this can be a problem because people who choose not to respond may be fundamentally different from the people who do choose to respond. So you're also missing data because you're not getting those people, but the problem is of non-response. So non-response, that's our potential source of bias. Next, subjects are asked to provide their heights and weights for a study. Oh, you don't ask people questions like that. People are not as likely to be honest, not because they're trying to deceive you, but everybody wants to be a little bit taller, everybody wants to be a little bit skinnier, or everybody wants to be a little bit younger, or you just forget how much you weigh or forget how tall you are. But these self-reported results, self-reported results self-reported results for things we can actually measure are usually not a good idea. You're less likely to get accurate results because people may not remember or people may see themselves through rose-colored glasses. Okay. An instructor conducts a survey by asking all students in her math class who use recreational marijuana to raise their hands. Tall and proud, raise your hand for all the world to see if you use recreational marijuana. Admittedly, here in Colorado, where we have legalized recreational marijuana, this may not be as big of a problem. But there are often places where folks don't like to admit that to everybody around them. They feel like it could get them in trouble. So, what we have here is a lack of anonymity. If you want to get honest responses to questions that are slightly sensitive, you need to make sure the responses are anonymous. People cannot feel like their answers may get them in trouble in some way. Okay. A poll conducted in a street market asks if shop owners would be allowed to play a high-pitched if shop owners should be allowed to play a high-pitched tone to keep rowdy teenagers from loitering at shop doorways. It's explained that this tone is irritating to most teenagers but imperceptible to most adults. What's going on here? What potential source of bias do you see? Well, we got some crazy phrasing going on here. Those rowdy teenagers are loitering at shop doorways. That type of wording is what we call a loaded question. You're asking the question using phrasing that may elicit a specific response. In this case, rowdy teenagers, we don't want them loitering. Yeah, let's do something about it. That's a loaded question. Alrighty. Well, let's go to the last page of questions and check yourself and make sure you, next page, okay, make sure you're feeling good about these. So address the following. A public health student gathers data on bottled water, unflavored, nothing added, use in her state. Her data indicate that households that use bottled water have healthier children than households that don't. She concludes that drinking bottled water helps to prevent childhood disease. Do you agree or disagree? Explain. Bottled water prevents childhood disease. And that's because households that use bottled water have healthier children than households that don't. Does that mean the bottled water is causing the good health? This is one of those cases where correlation does not imply causation. Causation. Just because these two things go hand in hand does not mean that one causes the other. Just because bottled water use and good health go hand in hand does not mean that bottled water use causes good health. There are lots of other things that could be happening. We have some potential lurking variables. What do households that use bottled water have going for them? Well, they can afford to use bottled water. So you could have money. Households that can afford to use bottled water can afford better health care, and therefore the kids might be healthier. People that buy bottled water, students in my class had a nice name for this: health nuttiness. Unless there's something wrong with your water, in which case money is going to be the issue if you've got unhealthy water in your house. But if you've got water that's safe and you use bottled water anyway, you just might be a health nut, which means you're probably doing lots of things in your household to keep the family healthy. So just because these two things go hand in hand does not mean one causes the other. Just like in the next problem, an education student gathers data on shoe size and math test scores for the same tests in school-aged children. He concludes that bigger feet cause higher math test scores. Do you agree? Let's think about something that goes on with kids. What happens with kids that causes both their feet to get bigger and their math ability to get better? Do you expect a fifth grader to be better at math than a first grader if they took exactly the same test? Do you expect a fifth grader to have bigger feet? Yeah, I think so. What we've got going on here is our common underlying variable, something that causes both kids, common underlying cause, that causes both kids to have bigger feet and be better at math. Our common underlying cause, yep, age. Older kids have bigger feet and they've learned more math. Doesn't mean that big feet causes good math skills. All right, here's one of my favorites. Inhabitants of the new, I don't even know how to say that, Hebrides used to believe that body lice improved their health. They observed that healthy people had body lice and sick people didn't. Is their conclusion reasonable? Helpful thing to note, body lice don't like high temperatures. So, do body lice improve health? Or is there something else going on? I think what's going on here is sick people often get fevers, which makes them hot and drives away the lice. So it's not that lice make you healthy, it's that being sick make the lice go away. So correlation does not imply causation. All right. If you have any questions over any of these, just want to talk about them, please, please, please send me an email. Give me a call. If I'm not in my office when you call, leave a message, and we can set up a time to talk by phone, by WebEx, or we can email back and forth, whatever makes you happy. But I would love to help make sure everybody feels good about all of these concepts. All right, take care.